Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
Timers and interrupts on the Raspberry Pi Pico using C. Let's get into it. Hi and welcome to RoboCraze. My name is Shiv and this video is the fourth in our series where I am teaching you how to program the Raspberry Pi Pico microcontroller using C with the help of a Raspberry Pi SPC. In this video, I'll teach you how to use timers and interrupts on the Raspberry Pi Pico. So we'll blink the LED using timers and attach an interrupt to the button to print a message on the screen every time the button is pressed. So let's get started. Let us begin by setting up the circuit. I have with me a button to which we'll be attaching an interrupt and an LED which we will be blinking using a timer and a current limiting resistor for the LED. So let us go ahead and wire this up. I'll connect the button to pin number 14 and ground. So pin number 14 is second from the right on the bottom, and I'll connect this to the two ends of the button there. And then the LED can be connected to pin number 15. Pin number 15 is the bottom right pin, the rightmost pin on the bottom over here. And through a current limiting resistor, the free end of the LED will go back to ground. The ground pin is third from the right on the bottom over here, where this gray wire is connected. So now that the circuit is complete, let us get into coding. So we can begin by having a look at the C++ SDK documentation. I'll leave a link to this document in the description down below. Scroll down and look for hardware_timer. Here we have it, 4.1.22. I'll click on it and you can see there is an example code over here where they're using both alarms and repeating timers. We'll go into the details of this, but first we'll look at a repeating timer. So we have a repeating timer callback. So this is the function that will be called after the timer has elapsed or the given duration for the timer has elapsed. In the main function, we begin by initializing stdio. This is for print statements. And they have first given an alarm example, but we'll have a look at the repeating timer first. So they create a new repeating timer object and then they use the add repeating timer milliseconds callback to create a new timer. The first parameter over here is the delay in milliseconds. So the time after which the timer will call the callback function. The second parameter over here is the callback itself, which they have called a repeating timer callback. The third parameter is any user data that we might want to pass to the timer callback function, but we don't have any, so we are passing null. And then a reference to the timer object itself that we have created over here. So this is how we will be creating a repeating timer. Over here you can see I have cd'd into the Pico C tutorial folder. This is the folder that I had created in the second video to put all our code inside instead of having to edit the examples given. So we can have our custom directory and not have to edit all the examples. So here we can begin by making a new directory called timer tutorial. Let's call it timer tutorial. And we can go to cmake lists and add it right now in case we forget to do so later. So we have to add subdirectory timer tutorial. This is so that our code gets built into the build folder. Then we can cd into the timer tutorial folder and nano into timer tutorial.c. And here we can begin writing code. I'll begin by writing all the include statements. So these are all the libraries that we will be needing right now. We'll also need the hardware GPIO library because we will be toggling the LED based on the timer. We can then define our LED pin using the hash define directive. So the LED pin is going to be 15 because that is what we have set up in the hardware. We can come to the repeating timer callback later. Let us begin by writing the main function first. So I have my int main function. So we can begin by doing stdio init all so that we can have some messages on the serial terminal. Next we create Next we initialize the LED pin. So GPIO init LED pin, and then we have to set its direction. So GPIO set direction for the LED underscore pin as GPIO out, because it's going to be an output pin. The button will be configured as an input pin. Next we have to create a repeating timer object. So that we do by doing struct repeating timer, and we'll give it the name timer. So our timer variable is called timer, repeating timer. Then we have to attach the callback to it and give it the timeout in milliseconds. So for that we use the function add repeating timer ms, because we're giving the delay in milliseconds. So we'll give it as 500 milliseconds, and then the callback function. We can name the callback function repeating timer callback. We have not created this function yet, but I'll create it in a bit. The third parameter is null because we don't have any user data to pass, and the fourth one is a reference to the timer object that we have created over here. So now that our timer is added, we can have an infinite while loop. While 1, and I can close the braces. Inside the while loop we don't really have any operations to be performed, so we'll just call this function called tight loop contents. So this will make sure that our timers and interrupts and all the callbacks are getting called on time. We can now go ahead and create our callback for the repeating timer. So for that we declare it as bool. Repeating timer callback is the name that we used. Repeating timer callback, and the parameters that it takes is just one, which is the struct repeating timer starting. So pointer to that repeating timer object. Over here we can toggle the LED over here, and for that what I am going to do is I'll declare a global variable called int LED value and set it to say 0, and here we can toggle it between 0 and 1. How we can do that is by doing LED value is equal to 1 minus LED value. So if the LED value was 1, it will become 0, and if it was 0, it will become 1. Then we can set it to the GPIO. So GPIO put LED underscore pin and the LED value. And just to see that, just to print this on the terminal to see when exactly this is happening, I can just put a printf over here saying LED toggled. So I'll just put a message over here saying LED toggled, and I'll put a new line character over here because that makes things much more neater on Minicom. And let me just check if we have everything that we need. So it seems like we have everything now, and we can go ahead and give it a shot, see if it works. One thing I forgot is, since it is a bool function, we have to return true. We can just return true over here. Now we need to build this. So what we can do is I can save it and then go into the directory where the code is present and nano cmake lists, or actually we can just copy it over from one of our older programs and then modify it for this one. So I can copy from our last code, which is analog.io. I can take the cmake list file into the current directory and edit it. So over here we have to replace all the analog.io with timer tutorial. So I'm just going to copy this and paste it wherever it needs to go. So wherever we have written analog.io, we have to replace that. And there we have it. So we don't need hardware PWM. We can change this to hardware timer since we're using that. Hardware GPIO, stdlib, and that's all. I can save this, close it, and go back into the tutorial folder. I can then go into the build folder and run cmake ... We should now see our timer tutorial folder or directory show up over here. And as you can see, we have it right here. So I can cd into it and run the make-j4 command. Make-j4 command. And while it is building, I'll connect my Raspberry Pi Pico in programming mode. So I press the button and I connect it to my Raspberry Pi, which is off screen right now. And we'll get a prompt. Also, we have an error over here. So I've misspelled hardware GPIO. So I can just nano back into timer tutorial.c, and I have missed a .h over here. You can save it and run it again. Our Pico is connected in programming mode, and once this is done building, I'll just copy the UF2 file over to the Pico using the copy command. It's just easier to do this in a terminal. Otherwise, you can use the Explorer over here to drag and drop your UF2 file. So I'm going to copy timer tutorial.uf2 to /media pi rp2. And as you can see, our LED is already blinking. I can go ahead and run the minicom command, and you can see every 500 milliseconds we get a message that the LED has been toggled, and we can actually see the LED toggle. Now let us add an interrupt to the button. Actually, before we add an interrupt to the button, let us have a look at an alarm. So what we have seen right now is a repeating timer. We can also have an alarm. And as you can see in this example, they have created an alarm for 2 seconds. So they use the function add alarm in milliseconds, pass it the first parameter, which is the timeout delay, which is 2000 milliseconds or 2 seconds. The alarm callback, so the callback function that is to be called at the end of this duration. The null is for the user data, and the false, I'll just search for this. So we have alarm pool. This is not what we want. This is the function we're looking for. Add alarm in milliseconds. So you can see the first one is milliseconds, the second one is callback, the third one is user data, and the fourth one is fire if passed. So what that basically means is, if true, this method will call the callback function itself before returning 0 if the timestamp happens before or during this method call. For now, we can just take it as false. So we can write a timer callback, and how we do that is by doing int 64 _t alarm callback alarm id _t id. So this gives us the alarm id, and then user data, which we will be passing as null since we do not have any user data to pass right now. So here we can just printf alarm fired. And we have to return a 0. I'll come back to this, what this parameter exactly means in a minute, but for now we can pass 0. So what returning 0 will do is, once the callback has been called and the alarm time has elapsed, it will call this callback function, and returning a 0 will just make sure that this alarm is not triggered again. You can return any time over here in microseconds, and the alarm will be triggered after that many microseconds again. So let us save this, go down and create an alarm as well. So we can say add alarm in milliseconds. Add alarm in milliseconds. Let's make it 2000, and our callback is called alarm callback. We do not have any user data, and fire if passed is false for now. So we have this. You can save it and go back into the build folder and run the make j4 command once again. Meanwhile, I'll connect the Pico back in programming mode. So our code has built successfully. I can copy the UF2 file over to media pi rp2. And then we can do minicom and our timer did not get called, our alarm. Let us see if we missed it by chance. So I'll disconnect it and reconnect it back, and minicom will automatically reattach itself. So there you can see, alarm fired came right between the LED being toggled. So the alarm fired comes at 2 seconds and the LED toggle is a repeating timer. What we can try now is going back into our code and let us return 2000 multiplied by 1000. So this is 2 seconds but written in microseconds. So we have to return time over here in microseconds. So 2000 milliseconds, I multiplied that by 1000 to get the duration in microseconds. So we can go back into our build directory, run the make command one more time, and copy over the UF2 file to /media pi rp2. Now you will see that the alarm will be fired periodically. So you can see every 4 LED toggles the alarm is being fired. The LED is being toggled at 500 milliseconds and the alarm at 2 seconds. That's why we have 4 LED toggles. This is how you can have a recurring alarm. But now let us have a look at interrupts. You can exit minicom. To exit minicom, you can press Ctrl A, then X, and then press enter. So now in order to create a button interrupt, we can first begin by writing a callback. So callback for that is written like this: void button callback, and the parameters that it takes are uint GPIO. So the GPIO at uint, that is uint GPIO, so the GPIO at which the callback was called, and uint 32_t events. So these are the events that occurred resulting in this interrupt. For now we can just printf over here that an interrupt occurred at pin %d with event %d, and then we can simply print the GPIO and the events, and I'll put a new line character over here. Now we'll take a quick look at an interrupt. So you can just search for interrupts. So if you come over here to hardware_GPIO, scroll down, you can see the function list. In this function list, we have a function over here which says GPIO set IRQ enabled with callback. This is the function that we will be using. So what this does is it attaches an IRQ, which is an interrupt request, and along with a callback. So we have to set the IRQ on that pin as enabled, the event for which we are enabling the interrupt, whether it is enabled or not, and the callback function itself. So let's click on this and have a look at what this function exactly takes. So first we have the GPIO number, the events, enabled or disabled, and then the callback. We can click here to see what are the events available. So if we set bit number 0, the interrupt event is a low level event. So it's it's a level triggered interrupt for a low level. Similarly, a level triggered interrupt for high level, and then a low and a high edge. So we can attach a both rising and a falling interrupt using these 2 bits. So this is for a falling edge interrupt, and this is for a rising edge interrupt. So let's have a look. We can go back in our code and we have created a button callback over here. We can go down. We can first actually begin by declaring the button pin as 14 because that is what we're using in hardware. We can then go down and set up the button pin to be an input and then attach an interrupt to it. So GPIO init button pin, if I can type it correctly, button pin GPIO set direction on the button pin as GPIO in, because it's going to be an input pin. Then we are going to set a pull up on it, GPIO pull up, because if you can see over here the button is simply connected to ground, so we have to give it an internal pull up so that when we press the button there is a falling edge, and that falling edge is what we will be detecting using this event 2. 2 means that the bit number 2 is set, so this is a value of 4 and this is a value of 8. So we can go here, GPIO pull up, and tell it with GPIO, so that is button pin, and then we can attach an interrupt. So this is a long function name, GPIO set IRQ enabled with callback, and this takes 4 parameters. So first it will take the button pin itself, then the event. So you can have event 4, which is a falling edge. Then we enable it by giving it a 1, and then the button callback function. And with this, our button should be wired up with an interrupt. So let us save this, go back into our build folder, timer tutorial, and run make-j4. Meanwhile, I'll quickly connect this in programming mode and copy over the UF2 file to the Pico. I'll wait for it to connect, /media pi rp2, and then run the minicom command. So you can see our alarms are firing, LED is being toggled. Now let me try pressing the button. And you see it says interrupt occurred at pin 14 with event 4. There is no new line character over here, which I'll be putting now. But as you can see, pin number 14, event 4, exactly what we had configured. Let us go ahead and configure another event. We'll attach a rising edge also. So when we leave the button, it goes from ground back to internal pull up. It's a rising edge, and we can detect that. So we can just put a bitwise OR over here. So we can put a bitwise OR 0x08, and then we can go back to the tutorials folder, run the make command one more time, connect the Pico in programming mode, and prepare the copy command. There we have it, media pi rp2, and then we can run the minicom command. So now every time I press or leave the button, we should be getting an interrupt. So I press the button, you see we get an interrupt, and I release the button, and you see we get an event 8. I forgot to put the new line character, but as you can see, we are getting both event number 4 and 8. So that is how we can attach an interrupt to a button. And you can see all the other things are still happening. Alarms still firing, LED is still toggling, and we now have an interrupt on the button. So that's all for this video, guys. I hope you enjoyed it. I hope you learned something today, and if you did, do leave us a like and comment down below if you have any ideas, suggestions or queries that you may want to share with us. Make sure to subscribe, because in the next video I'll teach you how to build a simple reflex game using 4 buttons and 4 LEDs on the Pico, and we'll use all the concepts that we've learned till now. So stay tuned for that one. Until then, keep learning, keep programming, and I'll see you in the next one.